Hello, this is Module 2, Investigation 4. We're going to talk about constant rate of change and proportionality. So constant rate means it's like a slope in the linear function. So constant rate of the change, we can call that as m. Okay. So here are two cylinders, one wide and one narrow. So one wide and the one narrow here. Both cylinders have equally spaced mark for the measurement, so which is the mark that you can see here. It's going to be equally spaced. And then water is poured into the Y cylinder up to the fourth mark. And then this water rise to the sixth and pour into the narrow cylinder. So the ratio between the wider cylinder and the narrow cylinder like up to 4, up to 6 in here. So A, both cylinders are empty and the water is poured into the narrow cylinder up to the 11 mark. How high would this water rise if it's poured into the empty Y cylinder? Okay, so the volume of the water would rise about the 6/4 with the empty Y cylinder, since it would be the rise to the 4/6 times the mark that water rose to the narrow cylinder. So in here, so ratio between the pour into the narrow cylinder, 11, and then we're looking for the, it could that be the, for the what happened to the Y cylinder here. So the narrow cylinder, the volume of the narrow cylinder over the volume of wide cylinder is going to be the 6/4. So if you simplify, it's a 3/2. So in here, so that's actually the ratio. So 11 over, which is going to be the mark on the narrow cylinder. And then we're looking for the mark on the wider cylinder. And then that's a 3/2. Then if you cross multiply, because of proportion, so if you multiply x times 3, which is 3x, equal to 2 times 11, which is 22, and divided by 3, x is going to be about 7.333. Okay, so that's answers. All right, B, imagine pouring water into the narrow cylinder and let x represent the height of the water reaching the narrow cylinder. As you pour, let y represent the height of the same volume of the water which if the pour into the Y cylinder. So we're looking for the meaning of the equation. So y over x equal to 2/3. So the equation we have here, y over x equal to 2/3. The equation means that this is a ratio, which is I already used in the letter A. The ratio of the marked number that the same number of water would be reached into the Y cylinder to the marked number this water reached into the narrow cylinder. So this is actually the its meaning of the equation meaning is the ratio of the Mach number between narrow cylinder on the wider cylinder. Sorry about that. It's because they put on the 2 on the top, right? Wider cylinder and the narrow cylinder. Okay. And then what does it mean by the y equal to 2/3 x in the context? So this time 2/3 times has been multiplied to the x. So this one is going to be just the Mach number. So y is the meaning of the Mach number in the wider cylinder. X is the meaning of the Mach number in the narrow cylinder. So the Mach number Let me write down with the blue. So the Mach number on wider cylinder is 2/3 times as large as the Mach number on narrow cylinder. Okay, but what about 3? In the number 3, now delta y, delta, if you see the delta, which means a change. So change in the Mach number in the wider cylinder, that will be the 2/3 times as large as the change in the Mach number on the narrow cylinder. So this one is the meaning of the Mach the change, okay? So change in the Mach number on the Y cylinder is 2/3 times as large as the Mach number, the change of Mach number, sorry about that, because of delta, change in Mach number on the narrow cylinder. All right, so the letter C, when x equal to 3, what is the value of the y? So in order to find the 3, I think I can use the equation 1a or equation 1 or equation 2. But since we have an equation number 2 here, so I want to use the equation 2 as an equation, y equal to, and then 2/3 times of x, since the x is 3, and then cancels out, so it's going to be 2. Now, x is a 4.5, same equation I'm using, 2/3 of 4.5, and then 3 goes 4.5, 1.5 times, and then 1.5 times 2 is going to be a 3. And then D, compare and contrast what the 3 statement, y over x equal to 2/3, y equal to 2/3 x, delta y equal to 2/3 times delta x, convey about how the water height and change the water height for the 2 cylinder are constrained and related. So, but actually the first 2 equations are the same as just a Mach number on the wider cylinder and then the narrow cylinder. For the third equation has a delta, which means a change. So the change, whatever change in the on the wider cylinder, that will be 2 times of the change in the narrow cylinder. Okay, so that's a little bit of difference. Okay, so then so proportion means you gotta compare. So proportion is about actually the changes. All right, let's go to the number 5. So in number 5, there is a 17-inch candle is lit and burns at a constant rate of 1.8 inches per hour. Let T represents the number of the hours since the candle started burning. So let L represent the remaining length of the candle. So let me draw the picture a little bit about the candle situation, okay? So we have a candle. So let's say this is a candle. And then it has a flame on it. All right, so the length of the candle was, the here to here was a 17. And then since it's burning, which means the length of the candle reducing, okay? So reducing speed is 1.8 inches the lower. So which means we're going to get the 2 things here. So let's say if you're going to say x for the length of the remaining candle, That means from here to here, it's going to be 17 minus x, which is going to be the length of candle. Burned. Okay, so we can think about this, okay? So what does the negative 1.8 represent? So it says 1.8 inches per hour burned, right? It burns at the 1.8 inches per hour. So which is each hour's 1.8 inches reduced. So 1.8 is the constant rate of the change. Since it's a negative, because it's the length is actually the reducing. So constant rate of the change of the candle with respect to the number of hours since the candle started burning. And then B, what does the expression 1.t represent this context here? So if the t is equal to 1, so 1.8 inches reduced, and then t equal to 2 means twice of the 1.8 inches reduced, isn't it? So that's the, which is it's going to be the length of the candle, which is in inches, has been burned. And since the candle start burning, of course. And then C, what does the expression 17 minus 1.x represent in this context? Since the 1.8 T is the length of the candle has been burned, and then you subtract from the 17, so 17 minus 1.8 T means it's going to be the length of, which is the remaining length. The candle, of course, is in inches. And after the candle has been burned for T hours. Is it the delta T proportional to delta L proportional to the delta T? Because L was the length of the candle, and then length of the candle keep changing. So delta T means the change of the candle, change in candle, and delta T is a change in time. So the delta L is a proportional to the delta T. So I want to say yes, because the delta L is proportional to the delta T, because delta L and delta T, they vary together as a linear relationship. That's what we call the constant rate of change, which means the rate is a constant, which is stays the same. Of the form delta L equal to m times delta T. In this time, the m is negative 1.8. Now, the question is it L proportional to T? I want to say no for this one, because L is not proportional to T this time. So what you mean is, when we're looking for the L, if we want to be the proportional, L must be the m times T. But this one, actually, that from L equal to, there's a length of 17 of the candle at the beginning, and then reduce 1.8 inches each hour, right? So because of the 17, that they do it from there. Yeah, so instead of this MT itself, we have a 17 minus. So it's not going to be the proportional for the data as equation. So how the variable expression and formula relate and different, okay? So the definition for the variable, variables are the way of representing the value of a quantity. But also the value is the varies. Its value is a varies, okay? But for the expression, also made by combining of variables and then constants, which is the constants and numbers. And then it also useful in apply the problem to represent the new varying quantity in the problem context. So in here, so variable means they use the variable as t and l like that, right? But in this problem, its expression is 17 minus 1.8t. And also a formula represents the value of the output, which is a dependent quantity, has a, in terms of the value of the input or independent quantity. So which is an equation, formula means like an equation, full equation. So L equal to 17 minus 1.80. So that's the difference, okay? Alrighty, so that's all about the module 2 and investigation 4. Okay, thank you for listening.